Okay, for example 1, we're going to find the composition of f and g and then the composition of g of f. And f of g of x means we're going to take our function f and we're going to substitute in g of x. And then your textbook will write it out like this. It'll expand it out like this. They'll literally put in what g of x is inside the parentheses. So they'll replace this g of x with x squared minus 3x plus 8, but you don't have to do that. I would just go ahead and start right away with substituting g of x into f of x. So f of x is 2x minus 5, 2x minus 5. And where the x used to be, I'm going to now substitute in what g is, which is x squared minus 3x plus 8. And then from there, we're going to go ahead and clean it up. I'm going to distribute. I get 2x squared minus 6x plus 16 minus 5. And then I have 2x squared minus 6x plus 11. And that is it. So f of g of x is 2x squared minus 6x plus 11. And then we're going to go ahead and do g of f of x. And g of f of x is my g function with f of x substituted in for all of his x's. And again, your textbook probably would write down what f of x is inside the parentheses, specifically what f of x is, which is 2x minus 5. But I would just skip that step and start substituting right in. Okay, g is x squared minus 3 times x plus 8. And now wherever there used to be an x, we're going to substitute an f, which is 2x minus 5. So I have 2x minus 5 in the first x, and then 2x minus 5 in the second x. And then this has a little bit of work to do because we have to FOIL. I'm going to expand out 2x minus 5 squared into 2x minus 5 times another 2x minus 5. And then I'm going to distribute my negative 3 or minus 3 right away to get negative 6x plus 15 and then plus 8 on the end. And let's go ahead and FOIL this out. You get 4x squared, and then we're going to have minus 10x again, and plus 25, and then minus 6x, and then plus 23. And now we're at the point where we can just combine like terms. I have 4x squared, and let's do negative 10x minus 6x is negative 26x. And then 25 plus 23 is going to give you 48, and that is done. And in the B example, not only are they asking you to compose the functions, but they also want you to plug in a number as well. So one method, which I don't really recommend, would be to first compose your function and then plug in the number. So f of g of 7 would use the first function that we composed here. We would do f of g first and then plug in the 7 right here. So that would look like 2 times 7 squared minus 6 times 7 plus 11. And then you would just simplify that. You could put it in your calculator. You could do it out by hand if you wanted to. And then if I wanted to do g of f of 7, I could first compose g of f like I did down at the bottom here, and then I could have plugged in the 7 then. So that would be 4 times 7 squared minus 26 times 7 plus 48, and then got an answer by putting that into my calculator. So f of g of 7 means compose f of g and then plug in a 7, or 7 is 7. And g of f of 7 says find the composition of g of f and then go ahead and plug in a 7. Now, if you don't want to compose the function first, because you can see there's a lot of simplifying to do and places where you can make a mistake, you can do the problem the way that I'm going to do it for the example. So let's start with f of g of 7. If you want to do this in 2 steps, here's how you could do it. You could first find g of 7 and then get an answer, and then go ahead and substitute that answer into f, and that's typically how I do it. So I'm going to go ahead and find my g of 7 first, and my g function is going to be 7 squared minus 3 times 7 plus 8, and I'm going to calculate out what that is first. So that's 49 minus 21 plus 8, and then I'm just going to use a calculator. I don't want to mess up for the video, and that's 36. And then I go ahead and take that 36 that I got for g of 7, and then I plug that into f, or I sub that back into f. So now we'll do f of 36, and that is equal to 2 times 36 minus 5. And then you have 72 minus 5, and that is 67. And that is my final answer. F of g of 7 is equal to 67. That's the final answer. It's the 67. It is not both the 36 and the 67. This is it right here. Now, if I first compose f of g and then plug in a 7, I should get 67. So let's just double check our work up here. Let's go back to the left side of my example where a is, and then I'm going to do 2 times 7 squared minus 6 times 7. I'm just putting this in my calculator, plus 11, and cross my fingers that it's 67, and it is. So I probably would not want to do it that way, because there's more chances of making a mistake with all the algebraic expressions in here, and distributing and combining like terms and so on. You just make one little sign error, and then this answer right here is going to be wrong. So I would do the method that I just showed you. And then also your Algebra 2 teacher might have showed you like a different way to write down the notation. And if you have another method you learned previously, or you like to show your work another way, that's totally fine, as long as you're doing correct math and you're getting the right answer. All right, so let's go ahead and do g. Oops. Let me go back. Let's go ahead and do g of f of 7. And that's going to be g of f of 7, like that. And then let's see what let's see what f of 7 looks like. F of 7 is equal to 2 times 7 minus 5. And that's 14 minus 5, which is 9. And then that 9 now that I just got for f of 7 is now going to be substituted in for g. So we'll do g of 9. All right, then we have 9 squared minus 3 times 9 plus 8, and that's 81 minus 27 plus 8. Just don't want to make a mistake for my video, and that is 62. And the final answer would be g of f of 7 is equal to 62. So 62 is the final answer. It's not the 9 and the 62, it is just 62. And then we go back here, and I'm just going to do a double check and see in my calculator what that comes out to be. 4 times 7 squared minus 26 times 7 plus 48 is 62. So that checks out. And again, I would not want to do the problem this way on the left side by composing the function first and then plugging in to get my answer, because there's just a lot of places where you can make a small mistake that messes up your final composite function before you even plug in any numbers. And then one last thing, when I'm doing a problem, I typically don't write my final answer like this. Most of the time I'll just box my final answer off that I get, and then that makes it stand out enough so you know that you don't have really two answers in each problem, you just have one final answer.